So, if we have to work with missing data, then obviously the first problem is that we are losing information. So if we are just checking the lecture notes, then we will have the following issues. So, is the data point missing because something happened? So the missingness is completely random, or the missingness is related to another variable, so it's because of something, or the missingness is happening not because of random errors, so maybe the computers were freezing down and then they were not able to collect data, but because there was a holiday. So not completely random, but still this can be the problem, especially if we are working with daily data. That's why I don't like to work with daily data, because different holidays in different countries can generate such an effect. And the problem with missing data will be that the computer will, or the econometric software will try to do something with this. And because they are trying to do something with this, then it will create biases in the results. So there are different methods how can we do the reconstruction, and the problem will be that each of them has its own problem. So first of all, we could say that, okay, if we have missing data here, so let's check. So here what we can see that we try to download the key policy rates for different countries in the sample, and the ratio of success was highly limited because, for example, for Romania from 2000 until 2002 we don't have any kind of a data. The same is valid for Denmark, or for example for Serbia. We can see that until 2006 there is no data at all. For North Macedonia, 2008, or for Sweden, which is also quite funny that sometimes they are just missing data here and there. So what is happening in the UK? For the UK, I think this is completely flawed data set because this is way too long. So I don't know what happened there, but this is a copy and paste error, definitely. So in this case, we could say that let's delete. So if there is any kind of a missingness, then let's start everything when we have the most data. So the precise name for this procedure is the last observation carried forward. Sorry, no. This one is the listwise deletion. So if we have any kind of a missing data, then we are killing this. Modes in this case already. For mostly data, it can be misleading because then it's troublesome. Until it's daily data, so until it's high frequency data, we will not see much bias because of this. So we can delete it. Just obviously the differential will be bigger because we are just jumping with the rest of the data which was available. Okay, this was not moving anywhere, but for example, in case of Bulgaria, then we will missing this information that it was increasing, then decreasing. In this case, we just see that, okay, it was decreasing if we are erasing this row here. And also when we had to work with Beata Udvaryon or paper, when she had annual data, so it was about 8 for different countries since the 60s, and the problem was that for one country, for 1 year, it was always missing something. So if I was just erasing years with missing data, then the whole database would be erased completely. So you cannot do that in this case. So there are alternatives. which says that, okay, we can do the last observation carried forward strategy. In this case, for Sweden, it's quite valid because we can see that this was not changing at all. So just the data is missing from the Reuters database. Otherwise, we can say that, okay, let's just copy and paste it forward. And still we can say that, okay, what happens here when everything is missing? In this case, we can say that we can reduce the sample. So, for example, we can just remove North Macedonia if its contribution is smaller to the, relatively small to the rest of the database. Obviously, this is a really small country, so compared even to the rest of the sample, then we can say that, okay, we can fire this one, and also we can restore the data here with just saying that, okay, it was constant, it was not changing. Obviously, the bias here, if you are just starting to reconstruct this one with the last observation carried forward, means that we will generate a lot of zeros after differentiation. So the difference will be here 0, 0, 0. Okay, it's central bank key interest rate, so usually they are not doing anything at all. So here it will be not a surprising fact that we will just 0 change, then 0.25 increase, then 0 again. So for this database, we can say that it's good enough. And after that, still we can say that, okay, let's ignore the first half of the database. And still we can say that, but let's not ignore. So what is the third alternative? And we can say that we can substitute the mean to the data. And in this case, I don't like it. So what I prefer for time series, any time series, where we know that the differentiation will have a mean of 0. So in this case, it's much better to do the differentiation at first. Then for the missing data parts, let's put in the zeros. At the end of the day, this will create the same data set what happened with the last observation carried forward, because in this case, we're just copying the last known data there. Then if you are doing the differentiation, there will be 0 because it was not changing. In this case, the mean of the data will be present there. So we can say that, okay, it's good. Because macroeconomic data sets are always behaving like this, so we can exploit this. And there is a fourth one, which is used by most of the econometric software. So this is the expectation maximization model. In this case, they are just running, so they are taking the whole data set, and they are assuming there is some kind of a relationship between the data. So they are in causal relationship with each other. And after that, it starts to go through until the first missing data points, and it creates a regression, and with this regression it tries to decide that what should be in the missing data point. And the name of expectation maximization is that they are trying to maintain the stability of the variance-covariance matrix behind the regression. The problem is that we can do this just after that. It will be really hard to use the same database for regressions because we just created an artificial relationship between variables. So what we reconstructed, it will be in causal relationship with the rest of the database. So practically we can do regressions on it. Just after that, we can see that it will be flawed. So p-values will be strange, and so usually it will be harder to achieve significant results. So that was my experience. We will test it later on, but usually this is the case. So if you can see that you have missing data in your database. And you can see also that intuitively some relationships should be significant in your database, but this is not working well. Then it's much better to test it with a dummy variable where missingness is highlighted with a 1, and otherwise if it's no missingness then it's 0. And in this case you can control that if you are just adding this dummy variable to the regression, then maybe it will stabilize it or it will be performing better. Because you have no other opportunities, so you can't make data up. It will try to do its best. SPSS is doing this, eViews is doing this. Matlab doesn't care about this. If it's missing data, Matlab stops and then asks you for do something. So it's not automatic, but also, if I know where data is also using EM method. And it doesn't require any verification or acceptance or anything like this. If it's a missing data within the data set, then it will try to reconstruct it with this approach. So that's why we have to be careful with that, because at least we should know what is happening in the background. So in this case, usually the problem is that if it needs times to ramp up, but I would like to create you nice database with flows. So already I loaded this Taylor key policy rate interbank 3 months, 1 year, and so on database. So let's just create Taylor rule here. For a Taylor rule, let's use Sweden. It's a nice place, and the data set is long enough and we have plentiful data. So we have the Taylor. Okay, this is the 3 months interest rate. We need inflation rate also from Sweden, also from 2000 BN cycle. Then we should just check it for Sweden. When does it start? It's also 2000, so it's good for us. So PG, open gap. Is inflation, and this is the interest rate. And since Sweden is one open and small economy, let's add real interest rates. And okay, this one is from the Bruegel Institute. This is Sweden. Okay, so we have everything here. We could say that, okay, difference between the inflation and the inflation target, but it would be the same number, it would be always 2%, and then if I'm doing the differentiation, I will just always looking for the change, so it doesn't matter if I'm just reducing it with a constant or not. So the problem here, that I think that this is already a differentiated. Yes, it looks like a differentiated data because it has a 0 mean. But the rest should be differentiated, so we can the output is okay, but we need the differentiation for the R, and we need differentiation for the foreign exchange rates. And also differentiation for the inflation. manual differentiation, I think, is completely enough, because just taking the difference of one variable and the other. Just starting the output gap here, so now it looks nice. Okay, so right now the data set has no issues, except at the end, because right now it has. So okay, let's delete this one. Okay, I copy it back to the database. So the problem will be that let's create a regression with this data without any missingness, and after that I just start to delete data points randomly, and we will check that how it will affect the whole set of results. So install just not now, and let's just have a simple regression. So the interest rate and the inflation, OBG, and the FX will be in some kind of a relationship. It looks nice, because if you are ignoring the fact that this data is absolutely affected by endogeneity, but this is for next week's class, but we can see that, okay, Durbin-Watson stat is good because it's between 0.8 and 2.2, so autocorrelation is not so present, it's not present. Also, we can see that this one is significant. So if inflation increases, then they should increase the interest rate. If output gap increases, so we are above the potential growth rate, then also interest rate will increase. And if the currency appreciates, okay, maybe what is the denomination here? Because in this case it says that we should go in the other direction. It's always good to check the Hungarian forint, because it has a tendency to depreciate. So the positive value is, yeah, that was the one the Hungarian forint was appreciating until 0.103. Yes, until 2008. Okay, so if it's positive, then it's appreciating, it's negative, then depreciating. So good. So it says that this is appreciation will be followed by, or sorry, it will have an instantaneous impact on higher interest rate, which is counterintuitive, but for demonstration it's good enough. Okay, so we can see that this should be the just have to change it from decimal points to decimal commas, because otherwise it will be crazy. And then we should start to add errors or missing data into the game. So what happens if I start to add, for example, in the inflation, I will remove. If we have no data, then what the best what we can do here, that okay, let's erase the first line where we have no data, only for the output gap. Right now I cannot do this because my equations would fail, but here I have to do it, or just reducing the sample by saying that okay, 2002 and 2, and then 2023 and 11. Now the first missingness will be ignored by the equation. Does it improve anything? Nothing, because it's a small line. But so intuitively, software can do or can solve most of it. But if you see anomalies, then you should check at least add dummy variables and check with the dummy variables. If still there is a problem, then you are in trouble. Obviously, once Isaac had this problem that he had really terrible data matrix, so he had just small amount of data sets. So in this case, you are not able to reconstruct anything. So it,
I thought that we can create dummy variable just in all their models. So you can do it in.
You can create dummy variables.
Oh,
so it's just
maybe I can create it in Excel, then I can.
Yes,
okay.
yes. No, in manually in Excel, this is the best, because in this case, probability of failure is less or way lower than when you are doing it with the software. So sometimes I had bad experiences, and it's more reliable or robust when you are doing it manually. Also, if you need, for some reasons, you need imputation or EM method for Matlab, there is also this imputation script, so you have to just copy and paste and this. There is it. I hate when it's doing the same thing, copying itself into itself. Okay, so this is doing the same thing. So this is an expectation maximization method, just for Matlab. And for some reasons in Matlab it was not included, so it's an external function, but it was developed by people from NASA for their paper, so it's good. So I will show you that. Once Matlab is going in, why so slow? Okay. So the whole thing is quite simple because it has one function, and you have to put here the matrix with the missing data, and this will provide you the matrix with the reconstructed data. So this is also using the expected maximization algorithm like Excel, like VViews or the rest of the softwares. So just copying it here. The rest of them is optional. We don't need this. I'll just copy this one. Sometimes it allows me to copy directly. Sometimes it's not. So let's see that today is which one. Okay, today we don't want to. Because it contains functions and other things and it's unhappy. So let's just manually grab. Recently they introduced these tables, but it's way better to just have. Okay, so numeric matrix, and now we just have to rename it to something useful, so it will be missing. So it already starts with missing data, so if it's something is none in Matlab land, then this is missing, and the rest is okay. So what we can do here, they have to be in the same folder to run this one. Where were I using the last? Why all the data matrix? Yeah, so for reconstruction you need at least one data point here and there. So it cannot reconstruct this one because there is no information. It will be able to reconstruct this one, so once we delete it. Okay, now it's able to see what's supposed to be here. So it created something which, according to this logic, it should be there. And here it says, okay, this is the same, this is the same. So this is artificial number, this is also an artificial number, and this is also an artificial number. So based on the information in the rest of the columns here. So as a worst case scenario, we can do it, and or if we are not doing it, then the economic software will do the same. And yeah. Okay, so that was all about missingness. Next thing is gotch. And